All right, we are going to jump right into this thing right here. And I'm going to make sure I'm hooked up. Okay. Who needs a ruler? Did I see everyone? You have a ruler? You do have a ruler. Awesome. You need a ruler? Okay. Ruler?
Yeah.
Okay. Okay. That's the idea I wanted to see. Hopefully I will. Give you an actual glass one. The fancy one, and you got the last one. I think that's all I got. That's it. Yeah, that's it. Okay, so what I've just given you is called a protractor. And you can take an angle, or you can measure an angle in there. So I see some of you doing it right now, which is awesome. I want you to be able to do that. We're not necessarily going to do it on those triangles, but we are going to do it on some of the triangles today. So practicing being able to do that is useful. So let me switch over here to looking at our assignment. Before we get into the nitty-gritty of measuring up the triangles, because we're not going to measure these triangles, we are going to measure these ones here, and you're going to draw on a piece of paper too. And I'll give you some paper probably to draw on. But let's just look at this one here first. Now, when we did right angle trigonometry, does anyone remember the story or the rhyme I told you? Sokotoa. Awesome. Some old hippie caught another hippie tripping on acid. Right? Tell me one of your other classes where you get to say that. Not too many of them. Right? Okay, so basically we have three different trigonomic ratios. The S is our sine ratio, our cosine ratio, and our tangent ratio. Or we just call sin, cos, and tan. Or sine, cos, and tan, whatever you want to call it. All right, and the O and the H is opposite side over the hypotenuse. And we talked about ratios before, how we're looking at comparing sides and looking at ratios. Well, we're doing a little bit of that today. And I told you the very first step we needed to always do is label our triangles. I figured why not kind of get started by just labeling the triangles that are in front of you. So I want you to label these triangles. Anytime you have an angle that's right here, that's the angle that you're going to name that relative to. And in this particular case, our hypotenuse is what I would generally tell you to label first. In this case, the hypotenuse is always going to be the longest side, so I will always put the letter H right there. And then you'll notice that I often do this thing. From my angle, I draw an arrow directly towards the opposite side, which I label with an O. And once I have those two sides labeled, the last one is obvious because it's the only one that's left. It's the adjacent side. Now what I want you to do is for these 6 triangles, I want you to do the same thing. Label those 6 triangles, label all the sides on them. All right? Relative to the angles that are in there. It's a little curved thing in one of the corners. So let's do that now. Remember this one, Caitlin? Yeah, good. Everything looks good, Sean. The only thing I do recommend is that I always, just to help remind myself, is that I always draw this. Anytime I have an angle there, I draw my arrow right here to remind myself which side is the opposite side. Okay? Okay, you all done that? Awesome. So the easiest side to label should always be the hypotenuse. No matter what, we can find our longest side pretty quickly. And then everything else goes relative to the angle that's there. And that's why I always try and encourage you to draw your little arrow straight across, just to keep track of where your opposite side is. And once you know those two sides, it means the remaining side has to be the adjacent side. And I think everyone kind of is similar to this here. All right, here's what we're going to do. I would like if you're in the front row here, I want you to take your desk and turn around and face the person directly behind you. So you're going to face the person behind you, you're going to face the person behind you, and Owen, you'll first face the person behind you. All right? And Sean, you can turn your desk around and face Caitlin. So you're kind of like distantly staring into each other's souls.
Wait, so you want us to move?
I want you to turn your desk around and face the person behind you. Not the desk right against that person's desk, but just facing them. And Harmony student, you can like just face each other there as well. You turn your desk sideways. All right. And you're going to go in. No. Okay. So the reason why we're doing this is this next part here is actually much more helpful if you work with another person. Now, the reason why I say this is because what I want you to do is you are going to draw a triangle with certain degrees for each one. On this chart here, we're going to fill in this chart. All right, so by filling in this chart, I would say one person would take the 10-degree angle here. So let's say I'm Summer. So Summer, and I'm working with KJ. So Summer would work on this one. And then KJ might do the 20-degree angle there, right? So what you're doing is you are drawing a triangle. I want you to draw a triangle with, so if I'm Summer, I have to draw a triangle with a 10-degree angle. All right, so I'm going to go like this. I'll take my protractor and I'll draw a certain distance here, and then I'll put a 10-degree angle on it. So on your protractor, yours is going to look a little different from mine. And I want you to make a right angle at the other end. So you're making your own right angle triangles. So this is my 10-degree triangle right here. Okay? And after I've made my 10-degree triangle, I'm going to measure my 10-degree triangle. So I have to label it. I would label my triangle relative to that side. So my hypotenuse is right there, my opposite side is here, and my adjacent side is there. And then I would measure all three sides. Now, you're all making your own triangle, so all your measurements for how long the sides are going to be slightly different, right? This is why you're making your own triangle. I'm going to give you a spare piece of paper in a second, and you can do that. Or if you can find space on your own page, you can do that now. But you're going to be drawing all the triangles. So you're going to have to draw a 10-degree triangle. You're going to draw a 20-degree triangle. I want you to share information with the partner you're sitting across from, all right? And so you kind of have to discuss and coordinate who's going to do which triangles. And there are 9, I believe, that are on there. So you're going to have to fight. Oh, there are 8. There you go. So maybe you could figure out how you're going to sort out who's going to do which ones. And then you're going to take the measurements, and then you're going to share the measurements with each other. Got it? Everyone understand? So you're drawing triangles. I'm going to give you some paper here so you can draw the triangles on. Let me grab some extra space. You can draw your triangles on. All right. If you're having trouble how to draw a 20-degree triangle or a 30-degree triangle, I can show you how to use the protractor. But basically, you're drawing a straight line, and you're drawing an angle from that line. So you might have to put a point using your protractor to show, like. Do you have a piece of paper? Okay. Just kind of like. All right. So talk with your partner and figure out which ones you're going to do. Well, your partner does half, you do half, and you're trying to draw the triangles and measure those triangles. You're measuring the sides, and you're putting that data in. I'm going to explain a little bit more. So in all these columns here, I measure the opposite side, and I put my measurement in there. I measure the adjacent side, I put my measurement in there. Make sure you're using the same units, too. If someone's using inches and the other person's using centimeters, it's going to be a problem, right? Just use centimeters. Inches are for the devil, right? Don't use inches because there's fractions, all that kind of stuff. And then once you put measure all your sides in here, you can do these calculations. You're going to take your opposite side and you're going to divide by the length of your hypotenuse, and it will give you a ratio. Okay? And you'll put that ratio in here, round to 3 digits. Round to 3 digits. Okay? So let's start that now.
Is that for the angle?
What's that?
Is that for getting the angle instead of the length?
Yeah, so no, once we've measured the lengths, these are lengths. These are measurements for lengths. Well, did it?
We're gonna die.
That was interesting.
No, I thought someone like went down to the base and I was like, fuck you guys.
Okay, we'll be coming back on here in a second, I'm sure. In the meantime, you guys can still measure now. The lights are back on, so.
I can't see still. Are you blind? Yes. They're still off in my head. My lights don't go on in my head. I'll be bottom floor.
Does anyone need a pencil? I have pencils.
I need a pencil, but is that like a sharpener or something?
Sorry?
Is there a sharpener?
A sharpener?
Yes.
Yeah, on the wall right there. That's the best one. Hey! Not just language, it's just offensive. Don't refer to people like that.
It doesn't matter the length of the triangle, does it?
It does not. It won't matter because it should give you the same no matter what. Vanessa's iPhone. Where is my Wi-Fi? Does it? Okay. All right, so these are all lengths. These 3 things here, where it says opposite, adjacent, hypotenuse, those are measurements for lengths. And let's measure in centimeters or millimeters or whatever you want to use. And then this is a ratio that you're going to get. And I want you to round to 3 decimals. All right. So you guys figure out who's doing which ones? People using telepathy? Is there some method of communication that you text each other? Did you guys text each other? Who's going to do which ones?
No, I bought them all.
Okay.
And then gone through that.
And you're all using centimeters?
Sure.
Okay. Yeah, so you don't have to make them the same. The bottom doesn't have to be the same lengths. You guys figure it out. All right, so everyone, show me your triangles. Let's see those artistic talents. No? Do you want me to try to use the protractor? Which ones are you doing? You don't know? Okay, let's see. Well, let's talk to this guy first. Which one is Summer doing? Or which one are you doing?
People may do more. Some do more.
So which one are you starting with?
I did 10 numbers and 20.
All right, so one, Summer, you'll start at 80 then. All right? So we're going to do an 80-degree triangle. All right? So we need a straight line, so draw a straight line for a triangle. Yeah.
Can I show you numbers? I wanted to hide it.
No. You already started doing the little ones.
That's your fault.
Yeah, it doesn't have to be, don't make it too long though, 'cause you don't want to be. And probably I would pick a measurement that's easy to use because you're measuring centimeters here.
Oh.
So that side's inches, right? The big one's the inches. So let's use centimeters. And I would probably make it a specific length, like 5, like try and make it 5 centimeters long or 8 centimeters long or something like that. So that way you're not stuck in between. Okay, awesome. Now, we need it to be 90-degree corners. So we need a 90-degree corner. So what you do is you take your protractor here, and you make it so the line on the bottom here lines up like this. And then we'll make it so that your straight line comes off of it at a 90-degree angle. So this looks pretty good to me. Like that. So 90 degrees, I put a little mark where the 90 degree is. So right at the top where 90 is, that's the 80. So you want to go to 90. Right above the 90. You are going to do an 80-degree triangle. I'm going to show you in a second now. Yeah, put a line there. Awesome. And what you're going to do is just connect the dots here for the thing. Like that, draw a line that connects those. Okay, awesome. Now we need to do 80 degrees from that point that you started off right here, right? So we're going to go right to where it kind of started from. You started at the corner of the page, basically.
I'll call that 4.
Like that. Now find 80 degrees. In fact, let's go like this. We'll make it easier on ourselves. Let's take the line all the way down this way until it gets to the 80-degree mark. See, so there's the 80 on the inside one. So you can either use the outside one or you can use the inside one. So if you're using the inside one, it'd be like this. And we have to make a mark somehow to make it mark. Oh, there we'll use the top part because it's the 100 part, right? Let's use that part. So see where the 100 is there? Let's put a dot. And let's put a little line underneath this. Underneath the straight line right here, let's put a little dot. So underneath it. Yeah, right there. Okay, so can I wait for a second? It's going to be like right there. So if we look at it to make sure that our 80-degree mark works pretty well. Okay, it seems close enough, so let's connect these two dots, like that. All right, so that's your 80-degree angle. Let's put the little curve in this corner right there. Like this. So here, that's your 80-degree corner, right? And then I want you to measure the lengths to the sides of those three different things here. And I want you to label your triangle. Why don't you label it first, actually? Where's the longest side? Yes, so that's your hypotenuse. Awesome. And then you're going to measure them, each side with your ruler, and you get your measurements. All right, how y'all doing? Make sure it's right angle triangles, right? You're making right angle triangles. What's going on? Yeah, so these are not right angle triangles. I know.
Have to do it all over again.
Yeah, you can just change. You don't do the whole thing over again. Take your sheet here, and instead of like figure out what the right angle is, you know what I mean, like that. And I would just make a little note underneath it. See, it's like right, basically right on there. Just like this, right on the 5, and then I would say right there, and then redraw the line like that, and measure that. So get rid of this. And remeasure this. So at least you can keep one side.
So instead of going to center and go 90?
Yeah. Then that's so you can find the middle, so you can find the 90-degree angle. Because now this is a 90-degree angle. Yeah. So now you can take your values here. You can take this value and divide it by this value. And then you're going to, whatever number you got, you're going to round to 3 decimal places. Yes. Did you measure it out? So, like, what's your length here? So you're going to start from the 0, right? So 0 to there is like what? 5? All right, let's just write 5 there. We're doing the bottom right here. And if you want, you can write it here. We're just doing measuring the opposite right now, but. And then after that, you can measure the adjacent side. How big is that adjacent side? Same thing. We take our ruler like this, and you measure it like that, and figure out how big that is.
So I just divide it.
Yeah, that's good. That's what I want. I want a ratio of 3 decimal places.
So I just divide it.
Yeah, so you exactly like that. Divide by this is going to give you that ratio right there. So this is your angle right here, right? Yeah, and then your angles are always going to be right on the inside here. So it's not always going to be relative to that.
So you did that for 90. How do you do it for the 80 and that?
So your angle for 80 is already done, right?
Yeah, but it's not, isn't it less?
No, so let's make it a right angle triangle, right? To make it a right angle triangle, we would just kind of like, you can take it like this. Let's make the 90-degree line up here. So you see here, the 90 degrees kind of lining up.
Yeah.
And then I want to line up at the edge of this triangle here.
Oh, I understand.
And now you go like this, right?
I understand.
And now there's your triangle. This, and that. So there's your opposite side, and there's your adjacent side. And just and measure these two sides.
So kind of go like that.
Yeah, or you can turn it sideways too, right? You can turn it sideways and keep the 90 on there, and then just find, like, if that's your 70, right? Put it like this.
And you line it up with that.
Exactly, and then line it up like that, and then you can, this is going to be, that gives you your kind of like right angle, right?
That makes more sense.
Okay, and what'd you get?
And I got 9, but wait.
So we count up, so 1, 2, 3, 4, 5, 6, 7. So I would write that, like, yeah, whatever, like, I would go like this. I'd say 0.7, because it's in between 0 and 1, right? Oh, we didn't see it. How's it going, Caitlin? Sean? All good? I've never used that type of protractor before. Is it looking out all right for you? Okay. How about you two? Got some values. All right, so these are going to be not angles. They are going to be lengths.
Oh, okay.
You know what I mean? So, like for example, if you did the 20-degree one, is this your 20 right here?
Yeah.
Right, so then all I want to do is, if that's your 20-degree one, right? That's 20 degrees right here. Just kind of loosely label it. And then this is your right angle here. So this is your hypotenuse. That's your opposite side, and this is your adjacent side. And I want you to measure the lengths here. Measure that in centimeters, and then put your measurements in here. And then when you have all those measurements done, you can use those measurements to calculate these ratios. Okay? Okay, that's fine. So if you recall, these trig ratio, like on the trig ratio table, sine, this is what your sine is, right? It's opposite over hypotenuse. Adjacent over hypotenuse is your cos value, and opposite over adjacent is actually your tan value. Now, if you recall, sine, cos were always numbers between 0 and 1. And as it should start off pretty close to 1 and goes down towards 0 as you go down. Whereas sine would be, it starts near 0 and goes towards 1 as you go up. And tangent will go from 0 and it can go up really high.
So I can't put 0.5?
So yeah, 0.5 here would be the right answer, right? Because it's kind of like on the way between this value and that value, so it makes sense. Okay? Yes? Okay, awesome. You want to help Summer with some of the other ones? Summer's doing the 80-degree one, right? And why don't you start doing the 50-degree one? Yeah. So now that you've made these measurements, right? And I want you to you have to be kind of precise on them, right? Like, it looks like you've kind of rounded to the nearest half centimeter.
No, that's fine.
Just 5 centimeters right on.
For opposite, so it's fine.
Okay. And then the adjacent was 1 right now.
A millimeter.
Yeah, so the millimeters count though, so make that 0.9. I know you don't want to, but you got to. Precision makes a difference. All right, see if we get our internet back yet or not.
Yeah, we do.
Yes,
All right. Let's see if everyone has disappeared on this or not. All All right, I'm going to take them up with you in just a few minutes. I'm just going to finish my attendance here that I think I forgot to do. All right. Why does it keep flipping out? Yeah, what's up? Question? Yeah, so far I think it does. And there's a way of double checking this actually, to some extent, and I'll show you how that works. I'm going to start filling these out a little bit with someone that, let's see how we can do here. I'm going to take one from each of you. All right? So who did the 10, 20?
I did. I'm just ready.
Okay. Did you do 10? I'm going to take
I
your...
did 10, 30, 50, 70.
Okay, I'm going to take your 10 here, okay? So you got 0.6, 3.8, and 3.9?
Yeah.
All right, so our ratio here was 0.6 divided by 3.9, and you get what? 0.154? I'll do your other ones, your other ratios that you have here too, actually. And you got 0.974 and then 0.158.
Are you checking if it's correct?
Nope, but I'm going to check to see how other people did. And we'll compare. Everyone's going to be slightly, like, there might be some slight differences. KJ, I'm going to take your 20% one here. So you got 1.8.
That's a 9.
That's a 9. 1.9.
5.
5. 5.4. So your ratio for the first one is 0.351.
Yeah.
And your next one you got was 0.926 and 0. Was it 3?
8, 0.
All right. How are you doing? How come your sheet's closed? Are you writing upside down, or like are you writing from the underside of the table? Is that what's going on? So share some values from KJ. Maybe you can help me out. You can hold it up. You got a 30% one on there? The 30 degree angle? I'm going to take your 30 degree angle. So the only thing that's going to be the same, or we're really looking to compare, you don't have to write down my answers, but the thing that's going to be of interest is going to be these ones here. So I want you to share between some of the people that you're working with. I'll just start off with some of these here. So 3, and then you had 3.4. And you got that ratio. So this ratio was 1.7 divided by 3.4, which you got as 0.5, and I'll add the other two zeros on there. And your adjacent was 0.882? Hate when that happens. 0.566. How about you, Caitlin? Do you have a 40-degree one I can put on there? Okay. This is 4.5, 5.6, and 7.3. I like it. Your triangles are really big. And you got, as your ratio, 0.616, 0.767, and you got 1.24 here. I think that one, I want you to look at that one again. How'd you get this number?
I divided the opposite and the adjacent.
Yeah, so 4.5 divided by 5.6. I want you to try it again. I think you went the other way around by accident. So your number, yeah. So your number's a little different. 0.804, I'll round off to. And the reason why I knew, if you're going to move your calculator for just a second, the reason why I knew is because I recognized this number is smaller than that one.
Yeah.
So I knew that it should be, it's going to be like this. So go back and check these ones too, all right?
Okay.
How's it going, Sean?
All right.
Which triangle are you working on?
I did 50 to 80.
Okay, awesome. I'm going to borrow your, actually, you know what? I'll let you calculate your ratios first, and then I'll check in on you. All right? So I have some up here. Now, your numbers aren't going to be necessarily the same as the ones that I've got up here, and that's not the point, really. But I have highlighted around this one section, and this is where the numbers are going to get interesting, is these numbers here. Are going to be probably kind of similar to what you had, right? So I think that, what, KJ, which one did I take from you? Was it the 20-degree one? And the first one, was that from you, Dylan?
No.
Didn't I take your numbers? Or maybe was it
No, I didn't
Harley?
even know.
Harley, I took one from Harley. And I took one from Megan, I think. And I took one from Caitlin. And what did you get? Have you calculated this at all, Dylan?
I didn't do those ones.
You haven't done this part yet? I want you to try it on your
I did
numbers.
the bottom one.
Oh, you did the bottom ones? Okay. What about, so you have ratios for all your bottom ones here?
Yeah.
Okay. I'll do those in a second. So if you want, you can either get from your partner the top ones, or you can copy the ones I've taken. Okay? Because I want you guys to fill out your table. Stephen, can I take some of yours? Or are you calculating your ratios? I'll let you calculate your ratios first. Yeah.
The ratios. Oh no, I understand now. Sorry, I'm done. I didn't.
Yeah, so now,
So high.
yeah, take your opposite and divide by your hypotenuse. And that's going to give you a value. And I want you to round that value to 3 decimal places.
Okay.
So again, we're just drawing triangles, and we're doing right angle triangles for those of you who are online at home. So here's my right angle. And some of you may have noticed that the 80-degree triangle is kind of annoying to draw because the proportions are a little bit different. Hi there.
You're not Miss Martino.
I'm not.
This is probably not news to anyone else.
No, I have a random class over here. So.
Okay, no worries. Hey guys, how's it going? Oh my god, now my phone. Okay. Alright, sorry to interrupt.
No problem. All right, I'll do the last little bit here with y'all. Does anyone have some of the later ones I can put up there? All right, let's figure this out. Oops, not like that. All right, I'm going to do some here with you. All right, you have a 60-degree one. Okay, so you have this as 1, and then your adjacent was 1.2, and your hypotenuse is 2 centimeters. Which triangle is that one on your picture?
I don't know. I don't think I drew that one.
That one, I think you got to. I'm looking at it because I feel like the numbers should be higher for your opposite side. It should be bigger, and so it's tricky with these these things here because essentially, if you have a, I'm going to bring a pencil too because I can help you out. Drawing these ones are tricky, especially with these like sheets here. So let's go like this for a second, like that. Like a line. And if I'm making a 60-degree triangle here, I could like go like this on there, try and make it line up right on that point there. And I find the 60, because I'm using the inside ones here, from 0 to 1060. So 60 is the same as like the 121 right there. All right, and then I can go like that. So this is my 60-degree angle. And then I need a 90-degree angle off of that. So what I would do is I'd use this solid line right here. And I know that this, going like this, is 90 degrees from it. And I go like, whoops, that. So there's my 90-degree angle. Right? And then, so now I can label my triangle relative to this. So this is the triangle. So here's my hypotenuse, here's my opposite side, and here's my adjacent side. And now we can make those 3 measurements. All right? So once you make those measurements there, together. So what do we got for adjacent, you think?
3.
Okay.
Or like 2.9.
2.9, all right. So it does matter. We want to get it down to the millimeter. It's going to make a difference. So that's our adjacent. What'd you get for that one?
4.8.
Okay. And the last one?
5.6.
Okay. Okay, so if we were finding the ratios then, so the first one is our hypotenuse over, or sorry, opposite over hypotenuse, so 4.8 divided by 5.6 in your case, and that would give us a value. And then the next one's going to be 2.9 divided by 5.6 equals some value. And the last one is the opposite, so it's 4.8 divided by 2.9. All right, and I'm rounding those to 3 decimal places. So if you haven't finished the table yet, I encourage you to keep going until your table is completed. If you don't have those things, share with your neighbor. That's why you're facing each other. Finish off your table. Or take more measurements, draw more. So there's the one that Owen and I did for 60 degrees. Keep going. Is your table all the way done? Oh, okay. I see what you're doing. How are you two doing? You finished yours off?
Yeah.
Okay. Now, I feel like your 70-degree triangle, I feel like the opposite in the hypotenuse. There's no way that they're the same length, right?
7 or 8?
On this one?
I don't know. I couldn't see it. I'm blind. I'm even wearing glasses.
The last
Oh.
one and the second
Yeah.
line.
They're a little different, right?
No, still the same.
They're exactly the same?
Yeah.
Lies!
No, I'm just that good at measuring.
No, it's not possible.
What do you mean? Oh, it is.
Oh, wait, I don't know. Hold on.
It's just very, very low chance of it happening. But if you look at the exact.
You're drawing some big triangles there, huh?
Trying to get the 80-degree one.
Ah, I see. Did you plot points?
I'm sorry, my hand.
Do you want me to show you my strategy on it? So my strategy with the 80-degree one is to go like this. In here. Okay. So you have like two sides here. If this is your right angle triangle, let's go like
Okay,
this.
one sec.
Is this a right angle here?
Hold on, I have to get out this.
Okay. That's for me. All right. So now I'm going to line it up to make it so it's about 80 degrees. So the 80 is right there. It's basically the equivalent of the 100. If we extend it, that's where the 100 is there. So what I'm going to do is I'm going to bring it until the 100 lines up right with it. Right with the other line. No, so there, that's it there. And then you have a little hole in the middle of the thing here, right? It's going to be the
I fixed it. Any question? Is that any
So you can draw the rest of your triangle. So
That's just a
now,
small casualty of.
here is your 80-degree angle, and label everything relative to that.
If any injuries occur.
Does that make sense what I just did?
Either fall.
Kind of, but
The lengths don't matter.
Power out.
The reason why is because the ratios are going to be,
I don't feel.
you could use any lengths you want. The ratios will still be the same. That's the magic trick of the whole, of the triangle.
But you questioned the 70, but not the 80.
Because 80 is going to be more likely to be closer. There's like a little, it still would be shorter. Like it's still going to be 5.0 compared to 5.1 or 5.1 compared to 5.2.
Do you have an eraser?
Do I have an eraser on the end of the pencils? But they're like the world's crappiest erasers. Do you want one?
Oh, they're the same.
I'm waiting for my partner to do her part.
You're waiting for your what?
I'm waiting for my partner to do her part.
I am.
She is doing her part.
I'm waiting for her.
All right, Stephen, let's see what you got for your measurements so far. So the first one you got is 5.
oh wait, I think now I'm confused.
It's supposed to be split 50.
Current IP configure IP automatic.
What?
I thought it was 5.
I don't know about that one, Mike. But
That's fine, I don't know.
Yeah, because
That's pretty
it
something.
seems like it's 5.
Okay, 5.
I think. I can't tell what number it is. 'Cause, like the line goes until there.
So which side's the hypotenuse of that triangle?
It should be this side.
Yeah, that's it right there, right? So measure that one and see how big that one is. Should be slightly bigger than whatever you're...
Oh, well.
Hi there. Come on in, Carol. So what are you thinking, 5.1? We're doing this right now, Carol. We're kind of like drawing out triangles, but if you want, you can just start kind of copying the table that we've got up on there. No yawning. Only if you're yawning to the band Yanni. No, it's actually just a dude. Nobody knows Yanni? Probably not. Before your time. Plays world music. They use this like music in like airline commercials and commercials for trips and vacations and stuff like that. All right, so you got 5, 0.9, 5.1, and so that your ratio here, you did 5.0 divided by 0.9, and you ended up with 5.55. Is that what you're getting?
Yeah.
All right, and let's try some of the other measurements. So you also had 5.0 divided by 5.1, and then you're also going to add 0.9 divided by 5.1. Oh, you got your table back? How about that? So you got 0.98. Is it 0.3 that's right there?
Yeah.
So I'll just go as 980. And then 0.176. Perfect. All right, I'm just missing 2 more ratios. I need 50 and 70. Does anyone have the 50 and 70? You have? Okay.
one's actually 5.1 and one's actually 5.2.
You did 5.1, 4.3, 6.6, and that gave you ratios of 0.772, 0.651, and 1.186. All right, and Caitlin, can I get one last one off you? You got the 70 ones?
Yeah.
Awesome. So you did 13.2, 5.2. Is this a 14.1 that's right there?
Yeah.
Okay. 0.9, 35, 0.369, and then 2.537. Awesome. All right. Now, if you guys want, I want you to kind of put this table down, and I want everybody to turn their chairs. If you're not facing the board, turn your chair so you can face the front here, because I want to discuss this with you. So everyone face the front. Okay. When you look at this, it's going to be different from your table. Your measurements are going to be different than somebody else's measurements, right? I've got like a weird mix of different measurements, which is awesome. That's really what I was hoping for. I've got some, like I got a big triangle that's right there, and I've got another big triangle that's there. Then I have some smaller ones, like that one there. And it's really important to this because at some point, somebody figured out that these ratios are basically the same. So your numbers, for example here, what did you get, Dylan, for this number right there, that ratio? What was the ratio that you got?
Same as that.
Exactly the same?
Yeah, because you said I can copy them.
Did I take your? I took Harley's, okay. Oh, you copied that one. Did anyone have a different number than this? Who here had a different number? Megan, do you have a different number than that?
Yeah,
180.187? Okay. And what about you, Caitlin? What was your first number that you had here? 476? Anyone else have one that was different than up here? This is KJ. What did you have for this one? 0.2. Okay, so there's a little bit of difference between the people, and that comes down to margins of error when we're measuring. So we're not using the most precise instruments, right? If we measured everything super precisely and we were very exact about it, we could figure out these ratios. All right, so we could figure out all we're doing is comparing the length of the opposite side to the hypotenuse. And that ratio, that comparison of those two sides, that's what this is right here. That's this thing. This is sine. Sine or sin is comparing the opposite side over the hypotenuse. And this thing here is like telling us cosine is that we're comparing the adjacent side over the hypotenuse. And then the last thing we were comparing was the tangent. And you'll notice that your values are kind of close, relatively close. And ideally, what else do we notice? Does anyone else notice any patterns that are developing here? What trends do you notice? Like if you're going through the sine column and the cosine column and the tangent column, what do you notice? Harley?
The second one is like declining as you go down.
Right, exactly. It's declining, like it's descending from what number do you think it starts at? Yeah.
0.97.
Yeah, so that's our top number there, right? It's close to 1 basically though. It's close to 1. And the closer we get to 90 degrees, the closer to 1 it gets. All right, and then here it's the opposite. So sine and cosine are kind of like opposite functions. Here it starts off low, close to 0 in fact, and it grows all the way close to 1. Notice how this number here, 0.980, is almost the same as 0.974. So that's the key thing. This value here is related. In fact, if we did this exactly precisely, it would be the exact same number. They would be the exact same. So they're kind of interrelated. So this value that we get here at 0.935, it matches up with this one, 0.926. They're supposed to be close. Right? So this here matches up with that one. And likewise, 0.857 matches up with that one. 0.772, look how close it is to the cosine of 40 degrees. So the sine of 50 degrees is the exact same value as the cosine of 40 degrees. It's all related to that 90 degree thing. So what do you think would happen at the sine of 45 degrees? What do you think happens there? What do you think the cosine of 45 degrees, if the sine of 45 degrees was 0.707, which it is, what do you think the cosine would be? It's the exact same value. So as sine is kind of increasing in its angle, cosine is correspondingly decreasing, but they're the exact same. So the cosine of 10 degrees on your trig value sheet is the same as the sine of 10 or 90 or 80 degrees. All right? And the only thing that's different then is the tangent thing. So tangent just goes right, and we notice it actually goes above 1. These ones here are ratios between 0 and 1, whereas tangent starts at 0 and it can go much greater than 1. It can go up to like infinite, really. And we can see it accelerates exponentially as we get closer to 90 degrees. So the point of doing this is you basically made a trig table. What you really made is this thing right here. You just made one of these by drawing your own triangles. That's how somebody figured this out in the first place. So a long time ago, in the desert, in a far away place, in the middle of Iraq and Iran, they figured out that if they found the cosine, or sorry, the sine of 10 degrees, it would be the same as the sine. So look at this value, right? 0.174 for a sine of 10 degrees. Let's go back to ours for a second here. What was our sine of 10 degrees? I think it was the same, wasn't it?
Yeah.
0.154. It's pretty close. And so that's 0.174. So the cosine of 80 degrees, right? If that's 10 degrees there, sine of 10 degrees, the cosine of 80 degrees should be the exact same. So if you go down to 80 degrees, there it is, 0.174. It's the exact same. So they're related, all right? And it doesn't matter what country you're in or what part of the world you're in. Anytime you draw a triangle, those side lengths, if it's a certain angle, will have the same ratio every single time. And by knowing those ratios, we're able to figure out an opposite side length, or we can figure out an angle between them. So we can use this trigonometry to figure out unknown variables, like the angles or like distances or lengths for a triangle, as long as it is a right angle triangle. Right? So your data is going to be similar. So the similar ratios, even if measurements were different. Why are the ratios the same when the triangles were different? Because proportions are got to have to be the same. It's like a recipe for, I don't know, chocolate chip cookies, right? If you make one batch or you make 20 batches, the proportions of chocolate chips to flour is going to be the same whether you make the small batch or the big batch. Proportionally, the sides have to be the same if the angle is the same. So we'd say proportions are the same if the angles are the same. All right, so what I want you to do now is take this triangle, these two triangles here. I want you to measure them. You have them on a piece of paper, right? They are different sizes. They are similar triangles, yet they are different sizes. You're going to do the exact same thing. Measure those. Take those measurements here, calculate the ratios, and let's see what we get between the small and the large size. All right, so use your ruler to calculate or to measure those sides. And here, I'm going to use your ruler. Very good. We're using the top one right here. That's what I mentioned, right? So let's switch over to this page here. So we're going to label our triangle. So I want you to label the sides first. Before we measure it, let's label the sides. So which side of both triangles there is the hypotenuse? Yeah, exactly. So I'm going to put an H on the above both. All right, and the angle is this angle here. So that's your interior angle, that one. So let's write for the little curvy thing there. Good. You do it on both. Awesome. All right, so relative to that angle, where's the opposite side? Yes, awesome. So let's label it on both of them as well. Put the O on the drawings. And so that means the last one is the adjacent side, so we'll put the A on that side. Yep. Okay, so now you're going to measure on the small triangle and the large triangle. I want you to measure each one of those sides and write those measurements into these 6 boxes here. And then you can take those measurements to calculate those ratios. All right? So just so everyone's aware, we're going to use this as our interior angle right there. So we're labeling things relative to that angle. Then I want you to take those measurements. Or you're trying to write that stuff down. All right. Awesome. Label, great. Measure those sides. Lay your measurements down. Okay. Okay, so make sure on your drawing, I like you to put your letters on there. It's always good practice too, right? Put your letters on the triangles to label your sides. Dylan, you all done? Let's take a look. What's that number?
This one?
Yeah.
8.327.
Okay, so it's 0.327. I feel like, what's this number? 4. Okay. So 4.9 divided by 2 is definitely not that. Because it's if 4 over 2, it's going to be at least double, right? Try to get that. But everything else looks good. And then when you finish that down, I want you to answer the question right underneath it. Yes?
So I measured just
Okay.
so like the 0
Keep going.
and that's the
So let's make sure we line it up just right, like, there you go. What do you got?
1.
Yeah, 6.1, right?
Okay.
Yeah, perfect. I like that. Good. I like that. Yeah. Yes. So some of you might be trying to figure out, wait a minute, do I measure the outside of the black line or do the inside of the black line? Whatever you choose to do, if you're doing the outside of the black lines, just do that on all of them. Make sure you're doing the outside perimeter of it, because the black line's kind of thick, right? Get those measurements. Awesome. So you're doing 2 divided by hypotenuse on 1. Wicked. So what do you got? What was your ratio that you got? Awesome. So I want it to 3 decimal places. So you're getting 0.3278. Now you can round up or down. So look at the 4th number. So if it's 5 or greater, that means you're going to round it up, right? So this becomes what? You're rounding the up, so you're rounding up, but you're not rounding up the fourth number, you're rounding up the third. So whatever number you're rounding up to, so if I tell you I want them to 3 decimal places, that means I want you to, like, the 7 is either going to stay at the 7 or it's going to round up to an 8. So you have to look immediately to the right of it. And in this case here, you have an 8, which is larger than 5, so you're going to round that up. So this becomes 0.328. Okay? All right, if you finish the ratios and you're on the table there, I want you to answer the question underneath that.
To do these, I know that you have to do the opposite over 5.
Yep.
So, like, what a way to
So put 2 divided by 6.1 and see what you get. How's it going, Harley?
These are almost the same.
Yeah, that's what I want you to notice.
Okay.
That's what I want you to write. All right, Carol, I'm going to borrow your numbers. I like your numbers there, so I'm going to take them. So I got to label this first. So use 2, 5.8, 6.1. And you got 2.8, 8.2, and 8.6. Okay, so what'd you get in your first ratio here? 2.8 divided by 8.6, and you got 0.326. Awesome. Keep going. 2 more ratios. And if you finish this table already, you can move on to the next one. I'm going to take this one up in like 2 or 3 minutes. And your numbers might be slightly different than mine. Everyone's interpretation of measurements is going to be a little bit different. What's up, Dylan?
Well, it has 2 different spots for angle here. Do we make another one or something?
I want you to do right that angle.
Oh, that
there.
angle?
Yeah.
Okay.
Figure out what that angle is. So you don't have to use your protractor. You could use the interior, some of the interior angle rule too. But either way.
Does it have to be exact, like point something, or?
Use the sum of the interior angles, right? All angles inside of a triangle have to add it to what?
180?
Correct. So you have 2 angles already.
Doesn't seem right. 65. Okay. Then I measure the outside again?
Yep. All right, I want to talk about this really quickly, everyone first. So there's a question here. And here's the question. What else do you notice in your original table, and are there ratios that appear more than one place? So if we look at the ratios that we came up with, so I'm using Carol's measurements. They're going to be a little bit different than your own, right? So Carol measured the first triangle 2.0, 5.8, 6.1. And did the second triangle 2.8, 8.2, 8.6. So from what we've seen from the first one, even though you're all very different people and you're all doing your measurements slightly differently from each other, generally things are the same. And we could see that from Carol's measurements, that Carol is actually super close, and like the ratios should be basically the same, and they are. Meaning that Carol's measuring is really consistent, and actually, right, look at these numbers, they're almost the exact same. So the ratios pop up. Even though the triangles are different sizes, it doesn't matter. As long as the angles for both triangles are the same, this could be the tiniest triangle in the universe, and this could be the largest triangle in the universe. The ratios from one side to the other will be the same. So some things are universal. All right, and then we could figure out what that angle is by looking at this ratio. And that's what we were doing before, was we were using the trig table to convert from a trig ratio into an angle. So we could figure out what that angle is. In fact, if I look at the table above, I try and figure out up here, here's right there, I have a opposite hypotenuse thing, 0.351. That's pretty close to what I was just looking at. 0.328, that's pretty close. And then that 0.351 corresponds to 20 degrees. And if you take your, I bet you if you take your protractor out, this triangle that you have in front of you, if you try and measure that protractor, or that triangle, it's probably pretty close to a 20-degree angle. Is it right on there? There you go. So we can convert between those things. So math is like a puzzle where you solve some of the pieces and it can tell you something else, right? If we know some universal truths about triangles or right angle triangles, if we know the side lengths, we can figure out by using the ratios to figure out what the angle is on the inside. And likewise, if I knew the angle and I knew one of the lengths, I could find another length. So those ratios can help us solve a mystery. I think I had one last one that was on there for you guys, and it kind of has this 25-degree one on there.
Yeah.
And the reason why I have that is because I want you to solve this, and then you have to figure out what this angle is here. How do I figure out what that angle is right up there? Dylan, how did we figure that out?
You take 180 and you minus 90 and 25.
Exactly. Right? Because all angles inside of a triangle add up to 180. So when I'm trying to solve for a third angle, and if I know two of them, I just subtract the other two from 180. All right? And then I'll be able to figure out that that is 65 degrees. Bravo. Okay, and then you could do both those there too. We got like 7 minutes until our break. If you guys want to work on that, you can. This isn't going to be the homework. Actually, I'm going to revisit something. So you may have noticed that if you recall, at last week, I gave you a page that looked like this.
You did?
Yes.
Do you remember this one? And I told you I was going to put that in the assignment and post it. Well, guess what? I did it this morning. I finally got around to it, and I am posting it. So no, it's not due today.
Oh, this one, yeah.
That's the one.
It's not done yet.
So there's a note that was related to it. There was a note that started off that looked like this, where I talked about a metric staircase, and we did these conversions, right?
Okay, done now.
About my metric staircase that we talked about. And then we did all these conversions about doing inches to feet, and we did ounces and to pounds and ounces to just ounces. And you've heard my giant tirade about how the imperial measurement system is just not good. Yes.
One stop with
Wait, we have a quiz?
I posted one at the end of last week. I think it's here.
Oh, there is?
Yeah, I think I posted it. I'm almost positive I did. And I told you to click on the link. And some of you started it last week. I want it done by the end of this week.
Oh, I finished that. Okay. I remember.
If you haven't finished it, I want it done. I actually said by today, I think. But,
I'll do it
I'm pretty sure that was quite easy.
right? What do you mean it's quite easy?
Oh, yeah.
What's the first one?
Oh, it's that one.
That was quite hard. That.
Yeah, what's my name?
Mr. Sean.
Okay, so KJ remembers it. That's because KJ is just like obsessed with me. So, I mean, I can't help it.
No.
All right. Yeah, there's this thing here. Oh, burn. Don't worry. You can't hide your true feelings from me. Okay, so I am going to collect back some of the stuff that you had. But that's what we're going to work on. You're going to have time, again, after our lesson, after lunch today. And, yeah, you actually know you can just leave those in here. I'll collect them at lunchtime.
Don't forget to spray them with sanitizer.
I am going to throw them into an incinerator.
What? Can I wash them?
No, I will not do that, actually.
What's the fun of that?
I'll check Miss Mark's Hold on, we're not going anywhere yet. We still got
I'm
like
not leaving them. No.
4 minutes.
What? 11:34.
Yeah.
I have a very.
That's a weird lunchtime.
Sorry?
I suppose I have a very important person.
Well, do you want to start at 11:40 as opposed to 11:35?
Why?
No, don't ruin it. Don't ruin it. Don't take a good thing and make it like go away, right? Exactly. Because then I could be like, no, I could say that the lunch is really 11:40 to 12. Whoa. But you know, with me, it's 11:35 to 12:05 until it gets ruined by someone, KJ. Right? Don't take a good thing and then go too far with it, because then like it's gone.
No. Well, don't say.
Scheiße.
Uh-oh.
I know that's hard to
There's a lot of lunch.
This feels really tight.
Yeah.
I know that's hard for you to do, but you can talk below.
It's not hard for me.
I don't think they're
not.
Yeah.
They're there. I'll find an appropriate GIF showing what they're really doing. Let's see here.
Not awake out.
What is that one?
Sleeping class.
This is what's going on at home right now. Right?
Just get data.
Nope. Yeah.
You can do data or a VPN, but you're paying for the VPN.
Nope. Hey, Brady, you know how you can't go on Snap on school Wi-Fi?
Yeah, you need data.
Yeah, I have that.
I use VPN.